Minus 30 seconds.
Real-time programs activated.
Minus 25 seconds.
PS2, PSLV open.
Minus 20 seconds.
PS1 ignition armor out.
Minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal.
P1 tracking. P3 tracking.
Magnificent liftoff of PSLV-C57 with Aditya-L1 on board.
Plus 15 seconds.
PSLV-C57 का सफल उत्थापन और इसके साथ प्रथम भारतीय सौर अंतरिक्ष यान निकल चुका है सूर्य के तेज से विज्ञान को प्रकाश करने।
Airlift strap on ignited.
इसके साथ ही एक और कदम है अंतर्ग्रहीय सफर में भारत की उपस्थिति सिद्ध करने का। आप देख रहे हैं PSLV-C57।
The bright fumes against a clear midday sky. The rocket launch is more than just a sight to behold. The roaring sound and the vibrations that we can feel here. Adding to this, the thrill are just amazing. Ground-lit and air-lit strap-ons operating together with the first stage S139.
Ground lit strap on separated.
जैसा कि निर्धारित है ग्राउंड लेड स्ट्रैप ऑन को सेपरेट कर दिया गया है और प्रथम चरण का निष्पादन सामान्य है। इस घटनाक्रम में अगला एयर लेड स्ट्रैप ऑन को यान से पृथक कर दिया जाएगा।
Air lit strap on separated.
जी हाँ, इसकी भी पुष्टि हो गई है। स्ट्रैप ऑन को सफलतापूर्वक पृथक कर दिया गया है।
We are 100 seconds past the launch time. The ground-lit and air-lit strap-ons have been separated. S139 motor still thrusting.
S139 110 सेकंड के प्रज्वलन काल के पश्चात उसे भी पृथक कर दिया गया है।
Plus 2 minutes.
द्वितीय चरण जो कि तरल नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है और वर्तमान में प्रणोदक उत्पन्न कर रहा है।
Performance normal.
From 2 kilometers per second to 4.9 kilometers per
Payload
second.
fairing separated.
The payload fairing covering the Aditya-L1 spacecraft has been separated. The current
Second stage separated. Third stage ignited.
goes to 5 minutes past the launch time. Presently, the third stage of PSLV is operational, developing nominal thrust.
जैसा कि हम जानते हैं PSLV सबसे विश्वसनीय रॉकेट रहा है इसरो का, वैसा ही प्रदर्शन करता हुआ एक और मिशन PSLV-C57 का।
For the present mission, after BS3 completes its burn duration, a coast phase of 200 seconds will follow, in which the rocket will continue to be steered while there is no development of thrust.
Vehicle performance normal.
Plus 9 minutes.
Speaking a few words about the Aditya-L1, describing the Sun, Indian Vedas and human space missions. The vantage point for such observations is a place in between the Sun and Earth.
Third stage separated.
Now we have a successful separation event of the third stage of
Separated
PSLV.
hosting. It is approximately 900 seconds.
Plus 10 minutes.
627 seconds from the launch. For another 600 more seconds or so, we will be getting tracking data from the BIAX ground station. Between the Earth and Sun is approximately 150 million kilometers. At the central region of the Sun, known as core, the temperature can reach as high as 15 million degrees Celsius. Power source for the Sun is nuclear fusion of hydrogen atoms that takes place in the core. The visible surface of Sun is relatively cool and has a temperature of about 5,500 degrees Celsius. The Aditya-L1 spacecraft is planned to be placed in a halo orbit around the Lagrangian point
Vehicle
1
performance
or
normal.
L1 of the Sun-Earth system, which is about 1.5 million kilometers from Earth, roughly 1% of the distance to Sun. A halo orbit is a periodic three-dimensional orbit near the Lagrange point in the three-body problem of orbital mechanism. The object in this orbit stays in place by the gravity of Earth and Sun. It requires little energy for station keeping. Several probes have been placed in space to observe the Sun by various space agencies. Lagrange's point L1 is a great location for solar explorers such as Aditya-L1, as it allows for an unobstructed view of the Sun that is never eclipsed by Earth. At L1, Aditya-L1 will join spacecraft such as ESA-NASA's Solar Heliospheric Observatory or SOHO, which has been at L1 since 1996. The Aditya-L1 spacecraft carries 7 payloads to observe the protosphere, chromosphere and corona, which is the outermost layer of the Sun. These payloads use electromagnetic, particle and magnetic field detectors. First among the 4 remote sensing payloads is Visible Emission Line Chronograph, VELC, which is a prime payload designed as a reflective coronagraph with a multi-slit spectrograph. This payload is developed jointly by Indian Institute of Astrophysics, Laboratory of Electro-Optical Systems, UR Rao Satellite Center, ISRO Inertial Systems Unit, and Space Applications Center. The second payload is Solar Low Energy X-ray Spectrometer or SOLEX to measure the solar soft X-ray flux to to study solar flares. This payload is developed by UR Rao Satellite Center. Third payload is the Solar Earth Ultraviolet Imaging Telescope, SUIT, which is a UV telescope to image the solar disk in the near ultraviolet wavelength range. The payload is developed by Inter-University Center for Astronomy and Astrophysics, Pune, LEOS, URSE and IISU. The fourth payload is High Energy L1 Orbiting X-ray Spectrometer or HELIOS, developed by URSE. Is a hard X-ray spectrometer designed to study solar flares in high energy X-rays. The fifth payload is the one which is meant for in situ observations. This is Aditya Solar Wind Particle Experiment, or otherwise called as ASPEX, which comprises of spectrometers to measure low energy particles and high energy ions. This payload is developed by Physical Research Laboratory. The sixth payload is Plasma Analyzer Package for Aditya, in short, PAPA. It is designed to understand the solar winds and its composition and perform mass analysis of solar winds. This payload is developed by Vikram Sarabhai Space Center. The seventh payload is a magnetometer or MAG developed by LEOS, which will measure the low intensity interplanetary magnetic field in space using a pair of magnetic sensors.
Vehicle performance normal.
Today, I'm joined by all the scientists who have played behind the scenes to make this project a grand success. And I'm Srinidhi, reaching out to you from the Aditya-L1 Space Center, Sriharikota. And so today we are joined by Dr. Anil Bharadwaj, Director of PRL, Professor Annapurni Subramanian, Director of Indian Institute of Astrophysics, Dr. Sankara Subramanian, Principal Scientist of Aditya-L1 mission, Dr. Durgesh Tripati, PI of SCYT, Dr. Dipankar Banerjee, Director of IRIS, Nainital, Dr. Satish Tampi, PI of PAPA, and Dr. Vipin K. Yadav, PI of Magnetometer, joining us today for a 25-minute fireside chat on the sidelines of Aditya-L1 launch. On to Dr. Anil Bharadwaj. So the sun is a very important energy source of life. Having understood that, it creates a trouble when it's angry. How does Aditya-L1 help us through the mission?
Thank you and good morning, viewers. First of all, let me tell you that Aditya-L1 is a multi-wavelength, multi-instrument and multi-directional mission. Multi-wavelength because it works in X-rays, UV and visible. Multi-instrument because there are 7 experiments on board. And multi-directional because it looks not only in the sun direction but also around it. Now when the sun becomes angry, there are 2 types of process which happens. One is solar flares, that means electromagnetic radiation, which reaches the earth in 8 minutes. But along with that, there is a mass which is also ejected out in form of plasma. And that can take about 2 to 4 days to reach the earth. What we are looking for from the Aditya-L1 mission is to see the impact of solar flares as well as coronal mass ejections as they come to the earth. We have instruments which look at not only in the sun direction, but also in other directions, for example, perpendicular to ecliptic or in the earth directions. The impact is that we need to see when the sun becomes quite angry, what are the ways in which it is affecting the planet Earth. And L1 point being at point L1, which is just 1% away from the Earth, it is able to provide us a lot of new informations of the plasma and the electromagnetic radiations which is reaching the planet Earth.
Thank you so much, sir.